It is nature's toughest puzzle, a biological fortress armored in abrasive spikes, hiding a fibrous wood core within a chaotic, asymmetrical oval. To dismantle this manually, stripping the armor to reveal the gold inside, takes a master with a machete 3 full minutes. But to feed a global appetite, this sterile processing facility cannot operate on human time. It must peel, core, and slice 100 per minute. This is not a kitchen. It is a high-velocity siege on biology. Before us lies a literal river of yellow gold, 80,000 pounds of fruit per hour moving at jogging speed. The mission is an engineering paradox. Force nature's random organic chaos into the rigid, perfect geometry of a steel can without bruising the delicate flesh. To achieve this, we deploy a monolithic assembly of hydraulics, centrifugal physics, and ballistic cutters. We're about to witness the transformation of a spiky, irregular plant into a mathematically perfect cylinder. From the muddy fields of the equator to the hermetically sealed stasis of your pantry, this is the high-stakes engineering behind canned pineapples. The invasion begins as thousands of pineapples arrive from harvest trucks, dumped unceremoniously into a massive water flow. This stage is deceptive. It looks like a simple wash, but it is actually a high-pressure decontamination protocol. The water acts as a non-Newtonian transport medium, cushioning the fruit against impact, while submerged jets strip away field debris, spiders, and soil to meet stringent FDA cleanliness standards. As the fruit ascends the intake conveyor, engineers face their first and most critical enemy: variance. In the wild, no two pineapples are identical. Some are squat, others are lean. If a small fruit enters a large cutter, it is pulverized into waste. If a large fruit enters a small cutter, it jams the line, halting an operation worth thousands of dollars a minute. Before a single cut can be made, order must be imposed on this population by the diverging belt sorter. This masterpiece of passive mechanical logic utilizes spinning grading rollers arranged in a V formation that widens by thousandths of an inch as the fruit travels. It works on a binary principle of gravity. The pineapple sits in the gap between rollers, which rotate the fruit, measuring its diameter 300 times a second. A size 3 fruit falls through the gap early, dropping onto a subterranean belt, while a larger size 2 rides the rails until the gap accepts its girth. The air vibrates with the deep, resonant rumble of thousands of pineapples rolling over hollow metal tubes, a gravitational sorting hat for the botanical world. By the time the fruit exits this zone, the chaotic mob has been segregated into uniform armies destined for the kill zone dominated by the JBT Jinaka processing machine. Invented in the early 20th century, the Jinaka is the AK-47 of food processing. Robust, violent, and utterly indispensable, the entire global pineapple industry is standardized to the diameter of its cutters. It does not peel fruit in the traditional sense. It fires the fruit through a die. The ballistics are precise. The pineapple enters the machine upright, where centering chains clamp the sides, aligning its vertical axis with surgical accuracy. Once locked, a linear horizontal ram, a hydraulic piston, strikes the base of the fruit. This is a ballistic impact. In 0.6 seconds, 3 distinct operations occur simultaneously. First, the ram drives the pineapple through a stationary, razor-sharp steel cylinder, shearing off the spiky outer skin in a single violent motion. Second, as the fruit is driven forward, a high-speed internal tube punches through the center, removing the fibrous wooden core. Third, the ends are lopped off by rotating turret blades. A rugged, messy plant enters the chamber, and a perfectly smooth golden cylinder exits the back. To maximize yield, the eradicator, a scraper mechanism, claws the remaining meat off the inside of the removed skins for juice production. The sound is terrifyingly rhythmic, the wet thump hiss of hydraulic rams firing 100 times per minute. It is the heartbeat of the factory, pumping out 6,000 perfect cylinders every hour toward the slicing department. While rings require a simple multi-blade slicer, the real engineering challenge lies in creating chunks or tidbits without turning the fruit into applesauce. To overcome the physics of friction, the fruit enters the centrifugal fury of the Urschel model RAA dicer. The mechanics inside are akin to a motorcycle wall of death. Pineapple cylinders drop into a stainless steel drum spinning at a terrifying 1,600 RPM. Inside this centrifuge, gravity is suspended. Centrifugal force pins the chunks flat against the inner wall with G-force intensity, making the fruit effectively rigid. Because the fruit cannot wiggle or slide, the cuts remain surgically clean. While pinned, the fruit passes vertical knives that slice it into strips, followed instantly by a horizontal crosscut knife. The machine uses the fruit's own momentum against it to prevent bruising. To the naked eye, it is a yellow blur accompanied by the high-pitched jet engine whine of the spinning impeller. The output is a waterfall of uniform cubes, expelled before gravity can reclaim them. This stream is now a chaotic river of 50,000 yellow chunks per hour. But hidden within is the enemy: camouflage. A tiny fragment of green skin or a black eye missed by the Janaka is often only 0.08 inches wide, impossible for a human to spot in this avalanche. This is why the line is guarded by the Tamra 5B optical sorter, an anti-aircraft defense system disguised as a conveyor belt. The fruit spreads onto a wide belt for a single layer scan. As it passes under a hooded sensor array, high-definition cameras and lasers analyze structure and density. To the computer brain, the fruit is monochromatic gray, while defects glow a radioactive red. The processor identifies a blemish and instantly calculates its trajectory. At the end of the belt, the fruit goes airborne. A bank of pneumatic air nozzles aimed at the falling curtain waits for the target. When a bad chunk crosses the firing line, pop. A precise bullet of compressed air blasts the defect out of midair into a reject bin. The sound is a staccato machine gun rhythm. Pop, 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 as digital snipers call the herd with 99.9% accuracy to ensure USDA Grade A quality. With the fruit sorted, the challenge shifts to packaging, getting chunky solids into a narrow can opening at high speed without bridging. Where chunks jam the neck and cause a pileup, standard piston fillers would crush the fruit, so the line utilizes a Solburn tumble filler to create a controlled avalanche. Instead of forcing the fruit, the machine mimics the geology of a Gold Rush sluice box. A massive rotating drum lifts the pineapple and drops it in a waterfall cascade. Hundreds of empty cans ride a tilted track underneath at a critical 45-degree angle. As they pass through the falling curtain, they catch exactly what they can hold. The tilt allows air to escape, preventing air pockets. It is a masterpiece of fluid dynamics. The fruit flows over the cans, and excess product simply tumbles off the rim to be recycled. There is no force, only a gentle, gravity-fed, chaotic fill. The soundtrack is a metallic clatter of aluminum shells overlaid with the wet, muffled slap of falling fruit. As cans exit, they are topped with syrup to displace any remaining oxygen and race toward the Angelus 60L seamer. Oxygen is the invisible killer. If it remains, the fruit will oxidize and rot. The seamer must create a hermetic seal, tighter than a submarine hatch, in a fraction of a second. As the lid drops, a jet of steam blasts into the headspace to displace air, which will later condense into a vacuum. Simultaneously, the can is spun to high RPMs as seaming rollers approach. This is industrial origami. The first roller curls the lid edge under the can flange. The second flattens this curl tight against the wall. This double seam interlocks the metal so tightly that even microscopic bacteria cannot penetrate. The audio profile is a piercing screech of metal on metal, punctuated by the hiss of steam as the cans enter the continuous rotary retort, a massive, pressurized steam cooker. They move along a spiral track, rolling constantly to ensure the liquid acts as a stirrer. This distributes thermal energy evenly to the cold spot, the geometric center, at 200 degrees Fahrenheit. This pasteurizes the contents without turning the fruit to mush, fulfilling the final stage of the HACCP safety protocol. The cans exit the cooker, cooled by water spray, and are palletized by robotic arms. In this facility, the concept of trash is obsolete. The cores are crushed for juice. The spiky skins are shredded and converted into high-energy cattle feed. Even the transport water is filtered and cycled back to the start. From a defensive plant in a muddy field to a stack of steel cylinders, the process has taken less than 15 minutes. On a kitchen counter months later, a tab is pulled. Click, hiss. Inside, the golden rings are suspended in time, as fresh as the moment the horizontal ram drove them through the steel curtain. It is a triumph of industrial will over biological chaos. A perfect circle every time.